Hello everyone, welcome back to my channel. This is Stacy. I'm very excited to do LeetCode problems with you guys. Today we're going to look at number 2 questions, I2 numbers. It's a medium level questions and commonly asked by some big companies such as Amazon, Apple, and Bloomberg. So let's start by looking at the problem. If we use one sentence to summarize the problem, it would be I2 numbers mathematically and then return the sum. Let's break it down a little bit. The input is two linked list number. In the algorithm, we need to add those two numbers, and the output is a linked list to represent the sum. There's one more key information in the problems, which is the digits are stored in reverse order. So what does this mean? As we all know, mathematically, it is unit, tens, hundreds, thousands from the right to left. However, in this problem, because it's reverse orders, which means unit, tens, hundred, thousands from left to right. The benefit of this information is we can calculate from left to right when we traverse the linked list. Next, let's look at the algorithm. The idea of the algorithm is fairly simple. Like we mentioned earlier, basically, when we traverse the two linked lists, we add the numbers at each position mathematically and then create a new node of the new linked list. Even though it sounds very simple, there are still a lot of details we have to pay attention to. First, let's look at this example. When we have 4 and 6 add together, we got 10, which means we have a carry 1 that will go to the next round. 3 plus 4 plus 1, we will get 8. This reminds us to keep track of the carry in each round. Secondly, when we talk about traverse two linked lists, the first idea is to use a while loop. And the condition of while loop is also very easy, which is at least there is one list we haven't reached to the end. When we put that into code, it will be either L1 is not equal to null or L2 is not equal to null. However, is that enough? Let's look at this example. Here, either 4 or 6 is the last node of the list. When we add them, we have 10, which means we still need to go to the next round to create a new node to represent the 1. This tells us even when L1 and L2 are both null, if the carry is not 0, we still need to do the while loop one more time. Thirdly, let's look at how we traverse the list. As mentioned above, the while condition is either L1 not equals to null or L2 not equals to null or carry not equals to 0. In another word, L1 could be null and L2 could be null. So what do we have to do? Yes, we have to do the null check before either accessing the value or going to the next node. Here we use conditional operator to do the null check. If L1 not equals to null, we can access L1.value. Otherwise, we give 0. Similarly, if L1 is not equals to null, we go to the next node by L1.next. Otherwise, we stay at L1. Last but not least, let's think about how we return the result. Because we calculate from left to right, thus we create the sum list from left to right. For example, we'll stop at 1 here. So how can we access the first node in order to return the result? Here we use a common trick by creating a dummy node, and then point the dummy node to the first node. So in the end, we could access the first node by dummy.next. Okay, enough talking about ideas. Let's look at a solution. First, we create a dummy node in order to return the result. Then we create a pre-node and point it to the dummy node. This is the pointer for the result. Next, we initialize the carry as 0. And then we get into the while loop. As mentioned before, the condition is when L1 is not equal to null, or L2 is not equal to null, or carry is not equal to 0. In the while loop, first we get the value of L1 and L2, but be sure to check the null before accessing the value. If it is a null, we just give 0 instead. Next, we calculate the sum by adding x and y and don't forget carry here. Next, we create a new node. The value is the remainder of 10. Then we connect the pre-node and the current node. Pre.next is the current node. After that, we update carry as sum divided by 10. Finally, we move the pre-pointer to the next node. The last step is to move L1 and L2 to the next node. Again, don't forget the not check here. If L1 is not equal to null, we go to the next node, L1.next, otherwise we stay at L1. Same idea applies to L2. Finally, we return the result as dummy.next. Next step, let's code together. First, we create a dummy node in order to return the result. Then, we create a pre-node as a pointer. Next, initialize carry as 0. Get into the while loop. The condition is L1 is not equal to null, or L2 is not equal to null, or carry is not equal to 0. Then take the value of L1 and L2. Again, don't forget the not check here. Same applies to L2. Here we calculate the sum by adding x, y, and carry. The value of current node is the remainder of 10. Then we connect the pre-node to the current node. Here we update carry as sum divided by 10. Then move the pre-node to the next node, pre.next. The last step is to move L1 and L2 to the next node. Again, here, not check. If it not equals to null, we move to the next node. Otherwise, stay as null. And finally, we return the result as dummy.next. By running the code, we realize there is a typo above. We fix that and run again. Everything works, and we spin the code. It also works. In the final step, let's review the key point again. First, we need to keep track of the carry. And then the while condition is L1 not equals to null, L2 not equals to null, and carry not equals to 0. The third one is check null before accessing the value or go to the next node. And finally, return dummy.next. As for the complexity, both time and space complexity, or O max mn, where m is the size of L1 and n is the size of L2. It is because we have to traverse each node of L1 and L2 in order to calculate the sum. Alright guys, here's all I have for you about this question, add two numbers. If you have any questions, please comment below. And if you like this video, please give it a thumbs up. Thanks for watching. I'll see you in my next video. Bye.